Okay, so Algebra 1, Lesson 7.3, we are working on solving systems. And we did it graphically last week. This week we are looking at solving it algebraically. So we did it graphically and by substitution. The last way is linear combination. And what you do with linear combination is you take your equations and you add them in a way that one of your variables is going to cancel. Okay? So you need to take your equations and arrange them so like terms are in columns. Okay? Then you need the coefficients on your like terms. So the number with your variable. It needs to be opposites on one of the variables. So you're going to multiply one or both equations by a number to obtain those coefficients. That are opposites on one of your variables. Then you're going to take those equations and you're going to add them together. Okay? This will make it so that one of your variables cancel, so then you can solve for the remaining variable. Okay, and then lastly, you're going to substitute this value into one of your equations. And solve for that second variable. Okay, so an example, we have negative x plus 2y equals negative 8, and x plus 6y equals negative 16. So the first step says to make it so that like terms are in columns. So here's my x's, my y's, my constants, and there's your equal sign. Okay? Then you're going to multiply so that the coefficients are opposite on one of your variables. If I look here, I have a negative x and a positive x. They're already opposites, so I don't need to do anything there. The third step says to add these together. So negative x plus x is 0. 2y plus 6y is 8y. And negative 8 plus negative 16 is negative 24. So I have one equation left with one variable. Now I'm going to solve it for y, so I divide by 8, and I get that y is negative 3. Then I take that and substitute it back in to get x. So I'm going to use a second equation because it's 1x. So I get x plus 6y equals negative 16, but I got y was negative 3. So I'm going to plug that in for y and solve. So I get x minus 18 equals negative 16. Add 18 to both sides and I get x equals 2. So the solution then is 2, negative 3. Okay? This is just a third way of solving these systems. I have 5x minus 4y equals 3, and 2x plus 8y equals negative 2. Okay, so the first step is make it so that like terms are in columns. Here's my x's, my y's, there's the equals, and my constants. So they're in columns, okay? The second step says that I need coefficients to be opposites on one of your variables. So I have a 5 and a 2. They're not opposite. I have a -4 and an 8. They're not opposite. So I need to decide, do I want to cancel out my x's or my y's? It's going to be easier to cancel out the y's because all I need to do is multiply this entire equation by 2 to make that opposite coefficients. So I get 10x minus 8y equals 6. And I didn't change this second equation, so that's 2x plus 8y equals -2. And then I'm going to go ahead and add them together, okay? So 10x plus 2x is 12x. -8y plus 8y is 0. And 6 plus -2 is 4. I can solve for x because that's the only variable left. So I get x is 1/3. Then I have to go and plug this in to one of my equations to get y. It doesn't matter which one, it's not easier, so again I'll use the second equation. So 2x plus 8y equals -2. I got y was 1/3. No, x was 1/3, sorry. So that would be 2/3 plus 8y equals -6/3. I just know that this has to be a common denominator. Okay? Then I subtract 2/3 from both sides. So I get 8y equals -8/3. And solve for y, divide by 8, which is multiplying by 1/8. So I get that y is -1/3. So the solution is 1/3, -1/3 as an ordered pair. Okay? All right, one more. We get 3x equals -6y plus 12, and -x plus 3y equals 6. Okay, so the first thing is like terms need to be in columns. So here's my x's, but then it's an equal sign. So general form is to put them in standard form, meaning put x and y on one side of your equation and your constants on the other. So in this top equation, I'm going to add 6y to both sides. Then I end up getting 3x plus 6y equals 12, and -x plus 3y equals 6. Okay? Then I need coefficients to be opposites. So I have a 3 and a -1. They're not opposite. I have a 6 and a 3. They're not opposite. So I could multiply, I'm going to say, let's cancel out x's. So I'm going to multiply this second equation by 2. The first equation is going to remain unchanged. Not 2, by 3, sorry. And then I get -3x plus 9y equals 18. Okay, then I'm going to add those together. So 3x plus -3x is 0. 6y plus 9y is 15y. And 12 plus 18 is 30. One equation with y left, so divide by 15. And I get y equals 2. Okay, then go back and solve for x. So I get -x plus 3y equals 6, but y is 2, so it's -x plus 3 times 2 equals 6. So -x plus 6 equals 6. subtract 6 from both sides. I get negative x is 0, so positive x is 0. And your solution then is 0, 2. Okay, so put x and y in columns, so they're both in standard form. Make sure either the numbers with the x or the numbers with the y are opposites. Add them together, solve for the remaining variable, and then substitute in to get the variable that you have not solved for. Okay, and that's linear combination. So that would be the third way you can solve a system of equations. Okay, so that is 7.3.